Tune in. Okay, it's on. All right, welcome to the Shop Class Podcast. We got a whole bunch of people here. What?
I gotta turn on my fan, man. It's freaking hot here today. It's 80. It was 88 degrees. I was out in the park cycling. I couldn't. I had to slow down. I had to cut it back to 12 miles an hour. I said, "Screw this shit. I'm gonna drop dead here." Hold on.
Get comfortable. Get comfortable. All right, that's Jesus Fernandez. He's the robotics instructor at the high school where I work, Memorial High School, West New York. We also got Duke in the house, Nick, Matt Bloomquist, Damien, and that was Matt. That was funny. And but tonight we're going to be talking about robotics. I'm curious about automation and coding, and I know nothing. But I do know that it's important. So starting off with the practical stuff, with the coding for robots, and then we'll get into like what you guys think of like how to handle the coming horizon of automated vehicles and automated machines and stuff like that. So yeah, so let's just start off with Vex Robotics. And I should say I really like that Jesus and a lot of people have chosen Vex because, am I right? It's like the stock car of robotic competitions. In other words, everybody gets the same pieces, and it really depends on what you do with it. It's not, you can't outspend somebody else. Am I right? Versus First Robotics, right?
Yeah.
Yeah.
Right.
So what do you? Yeah, go ahead, Duke. What do you think of it?
Vex, you can only use Vex parts, even down to like the rubber bands. You can only use the rubber bands. Whereas the First Robotics, they got sponsors and they're making they're sending the parts out to get CNC'd and milled, and there's really no set platform for First Robotics. This Vex levels the playing field. Everyone gets the same parts.
Yeah. And it's more about the First. It looks to me that First is more about the organization first. They're first than it is about the kids.
Yep.
It's more about the politics, the big companies, the sponsors, the politics behind the whole thing. It's I just don't like it. I like Vex a lot more. That's been my experience with Vex.
Yeah.
Did you know that Vex Robotics competition was named the largest robotics competition in the world?
Really?
I thought that First was the biggest.
No, I don't think so. And they're very expensive too. First is very expensive.
Yeah.
Oh, really?
Yeah. Yeah. With
I got to check on something. But what? So Jesus, how did you discover it?
Vex. You know what? I'm not really. I don't really remember, especially after this COVID stress. My short-term memory is really gone. I told you I suffer from acute CRS, and recently it's gotten more acute. But honestly I can't remember. How the heck did I get into Vex? I know. Oh no! Wait a minute. Yeah, the school I used to work in before, they had a small Vex. A small Vex program, but it was not. It was the Lego. I even forget what they call them. The Lego systems.
Oh,
and we used to we used Robot C as well at that time to program the little Lego, and then from there I said, when I left that school and I came to Memorial, then I said, why don't we just move on to the bigger platform rather than the little one? The Lego ones. I forget their name.
The IQs. That's the ones we use.
Right. It's similar to the IQ, but it was
the Mindstorms.
Yeah, Mindstorms. Right. Those
were
the ones.
Yeah. We started with those too, but the thing was they didn't come with a remote control, so it was all coding.
Right.
So what happens is with the Vex, you give the kid a remote control, and they're used to it like a video game. But then you tell them you can code it without the remote control, it just blows their mind.
Oh, that's cool. Interesting.
So it's like reverse psychology.
But at least you could get started with that remote.
Yep.
And is it wireless?
That hooks them. Yeah.
Yeah, the whole thing is wireless.
That is cool.
The interesting thing that I see happening now is that they're moving to autonomy. All the coding in the future for the Vex platform, in my opinion, I think is going to go to full autonomy. You're going to have to design the code to make the robot do everything on its own. If you look at the new sensors, they have the vision sensor that can see, especially detect colors in front of it, but you can upgrade that later on with better software to detect shapes, to detect different things. And not only the vision, they have the camera, they have the GPS system, inertial guidance system, that can locate itself right inside that arena, that 12 by 12. It can place itself right in the middle, and you can place it in the middle, initialize it, the way I understand it, and then it knows exactly where to go. So the whole thing is moving towards full autonomy. That's my opinion.
That's
Yeah, that's
amazing.
what I think is going to be.
Now, Damien, I only muted you because there was like a sound feedback, but you can jump in anytime. And then he said in the comments that they use Mindstorm at his school, but he doesn't have much experience with it. I'm the same way. Like we had some Mindstorms. We had there now. Jesus is using Vex, but like I don't have that much experience with it. But now all the automotive is going fully autonomous.
Yeah.
Not all of it, but it's coming. That's a horizon. And yeah. Now, what is like? Can I just take a naive approach, which I think is probably helpful for me, but not just me, like maybe other people listening or whatever, is what does the landscape look like? Maybe Duke, you could help as well. Like, I have no idea where C or C++ or A, B, C or D. I don't know what is the horizon there? Like, or what are we looking at here? Like, give me the short. Yeah.
Now there's like Java in the mix, Python's in the mix.
Yeah, like what's the difference between all these guys?
And it all basically does the thing.
What did he say, David?
I said I learned basic. That's how long ago I did coding.
Basic is that if this then that, if then?
Yeah.
You could make like a thing. It would be like if this then that. Yeah, that was home basic. Yeah. My cousin showed me it like once. Yeah,
Good. Yeah, you put like your name in quotes or something, like it's 10, make your name go to 10 and just repeat it.
Yeah, that was the big thing.
That's so funny. When I was like, I don't know, 12, I had a cousin that showed me it on our home computer, and he turned out, he was only, at the time, he was probably just about to go off to college, or maybe he was already at college for coding. He ended up working for IBM for like 10 years and then doing independent stuff for the next 10 after that. So had I known, I mean, he wasn't a great teacher. He just sort of showed me like one line. If he said, hey, this is what you can use it for. And just like you said, Jesus, or Damien, like you're showing the guy that what it can do. And then you show him the coding. Like you got to hook him, and same with me. I got to get hooked as well. Like, I don't know what, I never got into coding, but now that if I could program a car to do something, that'd be kind of cool. Or maybe if I could program like a charger or a battery management system to look after the batteries, that's kind of cool.
What's going to be cool is the, I'm sorry, go ahead.
Well, yeah. What's the difference between all these systems? Like, what is Python comparatively? Like what's that compared to like C++? I don't even know what that is.
They're both languages. The Python is it's more of a higher level language, easier to use, user friendly, more user friendly than C++ is. Easier to implement, but when it has his drawbacks too. You can't use Python where you could use Python where C++ is used, but there's certain things that Python can do. For example, Python cannot get into the guts of the system, into the guts of the robots. It can't. If you want to write what they call a driver, a motor driver, where you can power the motor, you have to talk to the hardware. In order to do that with Python, then you have to have a C extension. I'm not sure if extension is the right word, but it has to be a C interface, is the right word, to the Python language. So Python now has to be able to talk to C, and it's not difficult for Python to do that. Whereas, but it's not exactly easy either. But with C++, it's seamless. You can just
Oh,
incorporate the C language into C++. C++ is more powerful when it comes to systems programming. Uh, all the operating systems in our laptops and PCs, they're all based on C, which is like 50 years old. The C
wow.
language, C, and then C++ on top of that. Yeah, it's amazing. It but the Python language is much easier to work with. You can
Oh,
develop applications a lot faster. I come to you and I say, hey, I need an app for this. You know, can you do it in Python? Yeah, I could do it in Python. I could do it a lot faster than somebody who has to do it in C++. So those are basically the differences for me. You know, I've been out of the industry now for a while, so I don't know the details. Somebody who's in the industry at the moment could probably tell you in more detail than I
yeah,
can.
but you can give it from an education point of view. I mean, that's all we're at, right? This is the
Yeah,
education level
from a general
interest
standpoint,
anyway. Yeah.
I
What
could
about
tell you.
so if you want to run an app, like let's say you run an application on your phone, that could be Python?
Um, it depends. I mean, I know you the what's the Samsung system is based on is based. It's all Java. It used to be Java based. You could write applications in Java. I don't know at this moment if it still is Java based. And also it also had a lot to do with Unix as well. I understand that Unix was at the base of the operating system of the Samsung. I'm not sure. Now, when it comes to Apple, Apple has so many different languages they can use. They used to have Objective C. They also had, I believe, C++. They used to have as well. You could develop applications with. Then they came out with this thing called Swift. You can find it online too, which is what you develop code on for. I mean, applications for Apple. You can do it with Swift. You can. I don't. Objective C is it's already left behind us too. They're
Yeah.
they're moving towards more user friendly languages to use in order to write an app. So they don't want you to have to learn. They want to make your learning curve a lot less steep
So
than
like
it
let's
used to.
say
That's what they
yeah.
wanted.
So let's say like if you were looking at this landscape and someone was going to entry, like what do you teach in your entry level, where's the first what should they learn first, or even a teacher like me, what should I learn first? Ha ha ha.
Okay.
Damien put up the
I mean,
Uno,
if I don't
the
want to.
Arduino.
Arduino, yeah.
I'll tell you something funny. Let me tell you something funny about Arduino. A friend of mine had that like 10 years ago, like early on, I don't know. And he showed me it and I made fun of it and I said, because I thought it was a funny word, and I said, "Ooh, Arduino, aren't we fancy?" This and that. And meanwhile, I'm a jerk because I should have like been like, "Well, can you show me this?" Because he knew it was the future. He knew. This was way before anybody had it in their normal as a classroom. Timmy, how you doing?
Hey, what's up, everybody? Nice to see you.
All right. Tim, just to catch you up, we're just talking about the landscape of coding and the coming changes and advancements to basically to automation and possibly AI. So I was just asking Jesus, who works with me, the starting point. Like, what should you learn first? And Damien put up the Arduino. Now, what language is Arduino? And do you think is that the first thing someone should learn?
Well, I mean, hi, welcome. Let's drop a hard hitting question right in this guy's lap. It just joins into the meat.
Oh, what the question is for Jesus.
Oh,
Yeah.
I thought it.
No, I was just catching you up. You can relax. If you got an answer, jump in. You're welcome.
I was going to address that question. I mean,
go ahead.
it is a good one.
Absolutely. Yeah, it's a roundtable discussion. Everybody's allowed to. I encourage it.
So I had a coworker tell me that when I taught HTML, that teaching HTML is not teaching coding. and I beg to differ. I mean, yeah, HTML, C, whatever it is, you know, HTML4, HTML3, or whatever it was, or 5. Yeah, I think that initially is a introduction to coding. I mean, it's not syntax coding as in C++ or, you know, JavaScript or anything else like that. But I think that's a good starting point, you know, because things have to happen systematically, especially when you're designing web pages. Now, the web page world has totally changed because it's all WYSIWYGs now. So, you know, it is what it is. But, you know, when it comes to, I would say robotics and, you know, AI and things like that, I think starting off with Arduino is a good point. But you need to have an entry point, because jumping into Arduino, I mean, is no easy task, if you will.
Yeah.
Yeah,
Right.
our new syllabus for the juniors, like year 7 and 8, basically states that HTML isn't considered a programming language for coding, for our coding outcomes. And so that's where they say, I actually can't remember the terminology as to why they say it's not, but that's why they want us to use Python in particular, as one of the easiest things. Like these Edison little robots are programmable cars. You can use for Python to program them to go forward, turn right, move if they bump into something, and that sort of stuff. So I think that's where we're trying to head.
The Vex has what they call Vex Code VR. I don't know if you guys are familiar with it, and it is a very good introductory tool for kids to learn Python. They have the code blocks approach.
Oh,
And
what is this again? Say it one more time.
Is the Vex Code VR.
Okay.
Vex Code VR. You can just type that on it. It's a free it's a development tool, and it starts off with you can start off with blocks. You can connect the blocks, and it looks pretty much like it looks a lot like Python, and they designed it with Python in mind, because they use something called a list, which is one of the cornerstones of Python, is using lists. And they actually use that. They actually created blocks to work with lists, which I thought it was pretty cool. Yeah, you got it right there.
And similar to Scratch.
Yeah, it's similar to Scratch. This is exactly what I start my kids off with.
Yeah.
So it's drag and drop, but like all the
go.
quotation marks and the semicolons, they're all behind the scenes.
Yes.
So you're just getting the kids
Oh, so this stuff
dragging and dropping.
So this stuff on the left is the blocks.
Yeah, so grab the drive forward for 200 millimeters block and put it underneath the when started.
Okay, grab this one.
Yep.
And what do I do with it?
Just drag it underneath the when started.
Where's when started?
It's the yellow one on the right-hand side.
Oh.
That's how all the coding languages are. Your coding is on the left-hand side, your commands, and you drag it over to the right-hand side.
Oh, okay.
Now you got to hit the playground over here on the top right.
Here, start. Oh,
No, next to
playground.
it. Yep.
Oh, wow. Look at this.
Yeah,
Now move that over so you can see it.
Oh, yeah.
I think
This
Ron's
is
gonna
awesome.
be doing some homework tonight.
Right now look, change that number 200 to like something. Change it to like 1,000.
All right. This is cool.
Now just hit the play button down there on the playground.
Oh, look at that. I'm doing
Boom.
it.
And you know what
Great.
the other cool part is, Duke, I'm not sure if you're familiar with that, where you can convert that to Python.
Yep.
Yeah.
Look at you working in.
Convert it though, you can't go back.
Right. Sometimes you cannot go back. You're right. Or you can't. And there's an option where you can write it in Python, and unfortunately you cannot bring it back to blocks, which would be nice to be able to do that. But this is a great starting tool.
But it's nice for the kids to see, like, from this block programming, what it looks like in Python.
Yes,
They start making the connection.
What did I do wrong here? How come I can't get it to say hello? What is this?
Print hello. Because
And
it
it's
says
trying
it
to
on
move
the
off screen.
you have to open up the monitor, which is the little shell, I think. It's the little shell on the light blue bar on top right hand corner.
Here?
Yeah, I think that little shell, if you click on that, it's going to open the monitor. And I
Ooh.
think behind there, you could see hello. Run it again, and you might be able to see hello. I'm not sure.
Forward, drive forward. Oh, wait.
No,
How do I?
you have to
How do I? Oh, I
reset
got to
it.
reset. Okay.
Rewind.
Drive forward. Yeah. I went forward 1,000. He's going to stop right about there. Oh, there it goes. It wrote hello.
Print hello, right? Yeah.
That's great.
It's good for a starting point for the kids. But then later on, you outgrow it. You can't.
Yeah.
Yeah.
Because you can't customize or whatever. Oh, wow. Look
Well,
at
no,
this.
you go through the whole thing though. In a year, you go through the whole thing with them.
Yeah.
Oh, wow.
And you need more. You need more stuff if you really want to
What's
dig
that?
deep. Yeah, you could drop that in there where it says print. No, I don't know if you can drop that in there.
What is
See
it?
what's nice about this? Vex made this. So previously, like we used Robot C, it was only PC based. You couldn't use it on Macs. You couldn't use it on your
Right.
Chromebook. Vex came out with this during the quarantine,
Yeah.
and you can use it with Chromebooks. You can use it with Macs. You can use it with PCs.
Yeah.
And they did a nice job with it. And they wrote all these tutorials for it too.
Oh, because it's web based.
Yep.
Right.
See,
The
that's
kids
the
don't
thing.
have to sign in, so there's no like
Oh, wow.
age requirements.
Right.
Oh, I see. Blue is sensing. Yellowish is control. Looks
Right.
What's magnet?
It's you energize a magnet, it picks up metal.
No way.
Yeah.
Dude, that is pretty cool. Why didn't you show me this before? This is awesome. This is cool.
Simple things for simple minds.
I tell you what, it doesn't take much. It's true.
We know you, Ron. We know you.
This is awesome. That's really funny. Okay, cool. I like all this. This is interesting. So now, and so this would be a starting point. Like, okay, not just particularly this, but any sort of block coding would be a nice starting point, right?
Yeah, Scratch is very similar. So kids like will do coding with Scratch where they can make like scenarios or scenes, and it looks just like that graphical coding.
And what about our and Arduino now has on Tinkercad some block coding, right?
Yes, it does.
That one I was very interested in. Let me try and find it.
I used Tinkercad, but I did not use the block coding in my electronics class.
Well, Tinkercad has Tinkercad, the 3D drawing. They have an Arduino, and then they have the coding as well. They just started the coding.
Yeah, and then electronics. So they have like different portals, if you will.
And I think they have a microbit webinar coming up tomorrow at 4:00.
Yes.
What?
Yeah, and Arduino. Yeah, it's an Arduino microbit thing.
What's a microbit?
I don't know what microbit is. I never used it. I think it's like a similar to Arduino.
Yeah, similar to Arduino and a Raspberry Pi.
Yeah.
Is this Scratch?
Yeah.
All right. Interesting.
Wow.
And yeah, and where would I go? Where's the block coding situation? Start create. I was just trying to get the landscape. We don't have to. Oh, I see. There's the block. Oh, look at this.
Yep.
It looks like Xcode VR.
It's the same thing.
Yep. So, it seems similar. I think the elementary kids are trying to keep like the formatting pretty much similar.
That's a great idea.
Yes.
So you can click on the cat. You can change the characters on the bottom. You can drag in your scenes. You can tell them what to do. They walk 5 paces, make them say something.
All right, so let's see.
Wow.
So if I put that there, and
You have to have like a when started block, I think, somewhere though.
when
For your
started.
events.
What?
Go to like that yellow events.
Oh, events.
Yeah,
Yeah,
right there.
like that.
Yep.
And then how do I hit play?
Like hit that green flag, I think. I haven't done this in a year.
Oh, okay.
See,
Oh.
the cat said hello.
Oh my God! What the?
that is cool.
You can just type anything in here.
You can go down to the bottom right. You can change the background.
It's amazing how
You
kids
can
are
bring
being
in another
conditioned.
person. Yep.
Yeah, this is like a whole different thing. Wow,
And-
that's
and-
cool.
In another 20 years, man, these kids are going to be coding with their
Yeah.
eyes closed. It's unbelievable the amount what's coming. It's
Yeah, let's see. Move 10 steps. So let's just try that.
It's going to be an explosion.
That was 10 steps.
All right, guys, I got to go.
Yeah,
Assembly calls.
we
Good
we
to see
bored
you
them
again.
to death with the basic.
Well, this is the stuff I've got to try and learn. Some of my other stuff are miles past this, and I'm still trying to make the cat walk around. So,
Me too. I don't know what's going on.
Damien, how far are you from the Queensland school?
I'm down in New South Wales in Sydney, so we're a fair way away from Queensland.
They have like an online robotics program I was doing for a little while. They have some good videos on there, like the history of robots.
Yeah.
Peter Court.
History of robots?
He's sleeping, so I have to switch here.
All right, to try those out.
That's
All right.
cool.
I'll
All right,
hopefully catch
David.
you another week.
See ya.
Thanks a lot.
Have a good night.
Seeing you.
You're done with you me?
No.
Huh? Why?
Duke, what was that again?
The Queensland school. Yeah, Australia, and then do like
We should all-
robotic.
We should all take a trip and get together down there.
Yeah, I know. That'd be cool.
At a bar. Wow.
That's it.
Yeah, right there. Yep. So like, yeah, you can run through that, and there's some good videos on robotics, the history of robots, and everything.
Oh, wow. Here's
You have to run
introduction.
through them and find them.
See, this is good. It's just like a.
Yeah, this is a good one.
I need like an overview, you know?
This is it. Yeah, right here.
Wow.
It's and now you can see with the move to everything autonomous, you can see what's coming. It's
Yeah.
I think the Vex Robotics competition is going to be all autonomous.
Wow. No kidding.
Yeah, and that's because of COVID too.
Yeah, it accelerated it, right?
Yeah,
Well, that's the thing. Like, it used to be a lot of cooperation. Like kids used to run in teams, but
Right.
now like they used to go 30 seconds, hand the remote over to their partner for another 30
Right.
seconds. But with COVID, yeah, you're right. That's taken the cooperation part out of it.
yeah.
That's
And I
interesting.
could see it being just autonomous.
Wow. Oh, robots in history. That's cool. And how did you find this, Duke? You just got into it, dug into the web a little?
A teacher actually said, "Oh, there's this online robotics course you can take," and this was it.
Oh,
But like they got into it, you know what I mean? But I
yeah,
used stuff from the introduction part of it.
got it. That's cool.
But
Well,
they
this-
used like MATLAB or something like MATLAB, and I was like,
Oh, MATLAB. Yeah, that's a simulation. That's a popular one among engineers. That I know about. Basically, what you could do is you could basically simulate and predict an outcome based on inputs. So if you know how much the car weighs, if you know what the batteries are going to do, if you know the surface area the aerodynamics of it, the conditions that you put all this stuff in, and you'll get a number, and what it does is it's an open source thing. So like you can grab other people's code blocks, like this one's for aerodynamics and this one's for batteries or whatever, and you can always revise it or whatever. Believe it or not, Tesla used it early on to accelerate their development process. Yeah.
That's above my middle school level, kids.
Me too. I don't know what's going on. Yeah. That's cool. All right. So, okay. So basically, the situation is that you could start out. If you were going to start out, you start out with the blocks.
Yep.
Now, after the blocks, what would you do with Arduino? Would you go to Arduino, and what code is that?
Well, it's C. It's C++. It's a form of C++.
Oh, okay. All right. So if you were going to get into this, you start with the blocks, then you might do. Is that what you do, Jesus? You go next to. You start with the blocks, and then you go to C++.
Yeah, Python.
Oh, okay.
I go to excuse me. I go to Python. I start off with the blocks, then I go on to Python, and then I go on to C++.
Okay. All right. And then
Now, what are the V5 robots programmed in?
There right now you can program them in Python, and you can also program them in C++, and you can actually use the code blocks. I mean the Vex Code VR, Python version of Vex Code VR, yeah, to program it. Yeah, there is it looks just like the platform that the simulator that Ron had up there now. It looks just like that, and you can actually do Python code in there and program everything inside the Vex Code. I mean the Vex robot. Yeah, and there are also other Python simulators you can use to program the Vex robot.
Now those V5s, they just took over the old Cortex. Like all the Cortexes are probably so outdated at this point.
Yeah, they did. Yes, we still have some of those around.
Yeah, so do we. We use Robot C for that.
Right.
Yeah, I think the guy that teaches robotics at my school got rid of the Cortex ones.
Yeah.
Yeah.
What is Cortex?
It's another form of Vex of the Vex controller. It's a Vex controller, but it's an older version of it. The hardware remained the same, but most of it, no, some of it changed too.
I'll tell you what, I'm a little distracted by this because I'm seeing here the what they're calling the work cell, and I gotta tell you, automated factories is going to be massive. If I could get into this, because this is how they make the car. Everything for me is like car related. I just like how do you make a car faster? And these are
they've been doing that for the last 30 years.
Yeah.
Making cars like this.
Yeah, that's interesting to me.
Yeah.
Imagine if we could get this work cell thing. That would be really cool.
Well, it's going to be amazing in the future. I mean, I'm not sure how far off we are. It's going to be artificial intelligence and robotics. When you bring those two together, it's going to be freaking mind-boggling. And these kids today that are going to school, that are in the middle school now, and even earlier grades, obviously high school too. These kids are learning how to code so easily and so quickly. I mean, a lot of them are bored by it. They don't want to deal with it. They it's something that is just not in them. But some of them are into it, and it's amazing to see how quickly they just soak that up. But all these tools that we have today, they just pick it up so quickly. Sometimes they amaze me. Like I have a girl that she's unreal. This kid is amazing the way she picks up coding.
Uh-huh.
Sometimes she shows me how to do something I didn't see. I said,
Wow.
wow. All right.
On,
So
if
Yeah.
you Google Festo, Festo,
Oh yeah.
they have a big similar platform to this. They've been doing this for 10 or so years.
Autonomous?
Yep.
Yeah,
So,
Festo's a
yeah.
serious company.
Jesus is right. These kids pick it up quick.
Wow.
We went to that Sea-Perch competition in Drexel, and these college kids are helping us, and they're typing it just like it's like a foreign language to them. You know what I mean? Like they get it so quickly, and like me and the other teacher were sitting there, we didn't even know where to start.
imagine what's going to be like in another 20 years when you have all those when you bring artificial intelligence and robotics together, humanoid robots, all that amazing coding, because you're going to have such tremendous amount of code available to you. It'll be like picking parts from I need this driver, let me go here and get it and plug it into your application. I need that other thing, plug it into your application, and you can design code probably in a week that could take you months right now to do. You'll probably be able to do it in a week, years from now. It's just mind-boggling the things that are going to happen. Everything's going to move so quickly. It's like it's going to be too fast.
So what am I looking at here? Maybe the wrong thing, but basically, this is the automated side of Festo. Oh, technical education. Here we go. Learning systems. Factory automation. There we go. Control technology. Oh yeah! Wow, no kidding. This is interesting. Yeah, I want to get some of this stuff for the shop because it gives you a quick result. Like you can get kids simulating things pretty quickly. I'll have to explore this a little more. Educational concepts. Mobile training lab. That's what I've been looking. Whoa. These are like actual classrooms. They complete mobile training classrooms. Holy crap. Wow. You could just buy the whole classroom.
Yeah. They're not going to need us anymore.
I'll tell you what, man, this is interesting. I didn't know this company's selling entire classrooms.
Holy crap.
Yeah, here's CNC. Although the only thing I would say is it looks. All right, let's see metalworking. Metalworking. Hands-on essential automation and mechatronics technology, including various Yeah, but it doesn't look real. Woodworking? This doesn't look like woodworking. Can you imagine? Where's Tim? Tim, does this look like woodworking to you?
Not really.
How about food processing? That's interesting. Oh, here we go.
But
Oh, yeah.
I mean, I guess if this
it is real.
This is the route they're going to go. I mean, if you're going to be in a simulated type environment, that's probably what it's going to be. I mean,
yeah.
In 50 years, are there still going to be people teaching woodworking?
You're going to be the last one.
I probably am, and maybe you're the last one teaching welding. I mean,
yeah. So funny.
You know what I mean? I mean, I only got 13 years left.
Yeah.
So, what's the next 25 after that?
I don't know. I'll tell you what, there's no typewriter teachers.
I like to know what's going to happen next year.
Yeah.
Yeah, I want to know if I have a job next year. I mean, that's
wow.
I'm low man on the totem pole. Hey, is anybody hiring?
Yeah, we are.
I don't have PA certificate though. That's the only problem.
Oh, right. Okay. Yeah. What does it transfer?
No. No. So I gotta take a whole bunch of praxis tests
Oh yeah. Okay.
to get the PA certificate. So, but that's the next question. Are there going to be people teaching some of the stuff that we're doing right now? I mean, some of the
Architect's always talking about us being facilitators, and the teacher will be like the global expert. You just bring them in virtually, and then, which I don't care. I mean, imagine if they hired some super duper expert, and I was the facilitator. That's cool as long as we could still be creative. It's when it's not creative that to me is crazy. Like if I was just there to babysit. Nah, I wouldn't do that. I like that the attraction to the job. What gets me back there in September every year is that I get to, create, my own curriculum, and we can do stuff and get input from other teachers and other kids and this and that. So, if it becomes that it's all cookie cutter, yeah, I don't really like that. Like I don't teach science. I have no idea how anybody enjoys that, because what they're doing is they say, here is the outcome, now repeat. That's my impression of it. Whereas shop class, we don't know what the outcome's going to be. We're just going through a process of being creative. And to me, that's much more,
right. But there is still some cookie cutter stuff in woodworking to start. I mean, you gotta, cut a miter, and to cut a miter is the same way that you cut a miter for picture frame versus, trim.
Yeah.
So there is some cookie cutter part of that. And if you want to integrate a miter into a project, you got to know how to do it to be creative. So
yeah, totally. No, you got to start with the basics, 100%.
Yeah. So
yeah.
there is cookie cutter like that. Now does it go across different subject areas? Yeah, it goes across welding, because if you want to join two pieces of metal together, and do you want a butt joint or do you want a miter joint? That's the other, that's another thing too. So that there is some cross subject area. And even in the art field, like there's a lady at my school that teaches ceramics, and they do boxes. I think they do like some type of like a slab box or something.
Right.
And they join the corners of their boxes are joined with miter joints. And the kids that are woodworking related or have woodworking classes are like, oh yeah, we talk about these in woodworking class, or
yeah.
So there is, it does go a little bit deeper, if you will.
Yeah, totally. Yeah. I mean, yeah, you got to do the standard stuff. I mean, I start with like paper, drawing, it's not replaceable stuff. But how do you, now we're starting with the basics of coding. How do you get creative with coding? And, there's what Tesla's trying to solve, which I know I always talk about that, but it's relevant here. So what they're trying to solve is like, they were talking about this on the earnings call the other day. So imagine you're following a car and they need something called vision, right? So you're following a car, and on top of the car is a kayak, and somebody left a string hanging. And so the string's hanging on the kayak. The computer's got to interpret what the hell that is. Whereas a human in an instant would know that this person put a kayak with a little string dangling from it. And so you have all these weird corner cases, they call it, and you need programmers to be super creative and come up with ways that these cars will not, they don't freak out. Imagine if it's like slams on the brakes in the middle of the highway because it thought someone was out there. If it sees like what if it saw a paper bag cross the street? And how does it know the difference between the paper bag and like a person? Like my dad has terrible vision and he doesn't drive anymore. But when he did, because we didn't know, my sister and I didn't know how bad it was. And when he did drive, he saw a shadow and slammed on the brakes because he thought that a tree had fallen across the road. And it's like, damn, dude, that's crazy. So the computer might do something similar, So So you guys do when you do Vex, how much of this is vision based? Is there anything where the computer looks at something and tries to figure it out?
Not yet, though. I don't think, but it could get there.
Okay. Okay. Is there any vision at all?
Yeah, there is some vision, but it's only able to detect colors right now.
Oh,
Colored
okay.
objects. You could do that, but you can see
Okay.
this is it's the start. It's a
Yeah.
start, and it could get there eventually. It's not impossible to do. What you need is, oh my gosh, what you need is a lot of CPU power and a lot of algorithms, and that stuff it's there, but it's just a matter of bringing it down to the level of these high school robots. I don't know. I guess at this point it's too early. I don't know how you would do it, but the technology is there to do it. Yeah,
Oh, look, this
there you
is
go.
it, right?
Right.
But like to me, like just me. I'm well versed in all different subject areas, and I understand that. But like this does not excite me. Does not. I have no desire
That's
to
right.
do anything with this. This coding doesn't excite me. This robotic stuff doesn't excite me. It just doesn't. I mean, and
3D printing.
yeah, I don't doesn't excite me. It really does not.
Tim, it doesn't have to excite you.
Well, that's fine. But what I'm saying is,
No, I'm
If-
with you. I wasn't into this. I wasn't into this.
Yeah.
but if you said to me, all right, Tim, now next year you got to teach, 10 sections of robotics. If it doesn't excite you, how do you excite the kids?
Yeah.
Oh,
that's
no,
true.
100%. I just think that I'm not saying this is for everyone. I'm just kind of looking at what's going on. It's just really interesting because whether you like it or not, and not just you, me too. Whether you like it or not, this is going to be part of our future. So, like, for instance, like here's the vision software on a Tesla, right? So this thing is like looking at the truck and making decisions. It's I guess they call it painting or flagging. And so if you look at the camera, it's deciding what all these objects are in like super fast real time with double chip technology. So it's like if one chip goes down, the other one's doing, and it's also on board. So it's not like and if you look at the bottom, it says motion flow, lane lines, road flow, in path object, road lights, objects, road signs. And this is like a thing, So you got to figure out a way to make it exciting. And I'll be honest, in my own area of metalwork, I don't find G code and CNC that exciting. I think the result is exciting, but the work it takes to get a machine to run CNC, I just haven't put the work in because I'm not that excited about it. But I think that with the block coding, it's getting there. Like for instance, even robots there were no robots in the in the classroom until Vex made it popular and stuff like that. I mean, there were probably, but you see what I'm saying, Tim? Like, I think you need an entry point, something like this,
Yeah, I mean, I understand that, and I mean, if I wouldn't want to teach robotics for 13 more years, I can tell you that much. And but how do you get excited teaching stuff that doesn't excite you? I mean, I think in the end, that's a philosophical topic for another day. You know what I mean? And I agree with you, Ron, that to have a car that self-drives, that's freaking cool. But designing that, I have no desire to do that.
Yeah, I'm with you. Like I like driving. I have a 96 Ford Ranger that's my daily with a 5-speed stick shift. Like I love driving. but I'll tell you what, if I'm on a long trip, this is kind of cool. So how does this happen? And the way it happens is robotics, vision, software, coding, programming, and the control. Basically, this car is a robot. It is not a normal car. And then for me, same thing with with CNC cutting. Cutting it by hand. A milling machine cutting out and feeling it. You turn the knob and it goes, and now you're cutting too hard. All this stuff. Or you use programming and it and it knows where all the stops are and whatnot.
And you know what though? I mean, like I said, it doesn't excite me. And in the end, when it comes to like the first robotics and the Vex Robotics, I mean, you need that. You need that so that the kids can get to this point, right? I think that's what it is. I mean, if you look at the new first robotics, like the top tier robotics, where, making a robot from scratch, there is a vision element. There is an automation element. There is a, synchronous element. There is a human powered element. So they have all of that stuff in there. So there are people that it does excite and that can do this.
Yeah. And also think about it, if you've ever been to one of these competitions, it is kind of exciting, to see what's going on. Whoa.
Now that was a cool game. The Steamworks, I volunteered. I helped my school with the Steamworks competition. That was actually a pretty cool game. And when it was, all right, we gotta fabricate a model for, say the ball shooter, or we got to fabricate the launcher or whatever, I'm all in. But then when it was one of those, like, well, we need to change the programming to make this shooter work versus another type of shooter, I was like, forget it, I'm out. Because like I said, it does not excite me. I want it to happen, make it happen. And there's people that are good at that. And I don't, and I'm not downing them. I'm not. I mean, it's just,
Yeah, that's why it was always very difficult to find people in industry that love the mechanical aspects of design, putting things together, designing them first of all, putting them together, and then they would also love writing the code. It was always very, when I worked in industry, very difficult to find people like that. And when you found somebody, you wanted to hold on to them and pay them as much as you could.
I will tell you, there is, like, for instance, nobody wants to do their taxes. Nobody wants to do their P&L statement, profit and loss statement. Nobody wants to do the boring data writing down of things, or you want to make stuff like but I got to tell you that if you do the data, you actually crunch the numbers, and you, in a way, you're kind of like writing a code. There's a lot to learn. Like, you would gain a significant advantage. Like I gain so much advantage when I look at the data, and that's basically code in my eyes. So I know what you're saying, Tim, but imagine if you were able to look at the data and crunch the numbers. There is some exciting parts to that. It's very valuable, is what it is. It's just
I'm not saying it's not. It's not.
Yeah. No, I'm saying it's
exciting
in that way. Yeah. So all right. So now let me swing this back to the situation that you have. So you start out with this. You might do some of this, right? Then you get into C++, and then now what is the best? What's the top thing that, Jesus, that you've done as far as coding goes? Is it always applied to Vex, or is there some other thing you're working on?
It's hard to always apply it to Vex, but you could for the most part you could, but not all the time. The biggest problem we had this year obviously was COVID, because you could teach. See, you could teach, for example, you could teach C++, and you can apply it to the Vex, but you can't do that with this simulated tool. You can't do that online. You need to have the actual system with you. So you can't do it in an environment like the one we are in now. But you could do Python. You can teach Python with this simulator. You can start with the blocks and you can move on to Python, and you can still see the correlation between the robot, the simulator, the blocks, the Python. When it comes to C++, then there is no such tool. You need the physical robot. You need to be around the robot. It could be done. We've done some of it in the past. We did a good amount actually in the past, but then we couldn't go any further. We just couldn't because of the restraints due to COVID. Because you need to be physically there with a robot when it comes to the C++.
And to Tim's point, like making something, is very exciting. And yet the opposite is true with some of the students, is that they like the coding, but they have no interest in making the robot work, and so that's where like for instance, my supervisor came in the other day and he said, hey, I want to do Arduino sustainable Arduino in September. And I was like, that's Jesus's class. My class is the mechanics of the thing, the metal fabrication mechanics. And he means well, but he was just excited about, robotics. And I was like, yeah, that's great, but we got to ramp up to it because, what we're trying to do here is get the kids excited about drilling holes in steel and putting bolts in so you can make an arm articulate. You can make an elbow or something like that.
But some of them, Ron, are just totally happy with taking some pieces of plywood and some pieces of cardboard and hot gluing them together.
Right.
And then they wonder why, their set arm won't work. And then you're like, well, because you have no gussets, you have no bracing, you have no structure, you have no integrity in your design. It's, hot glue is not a good fastener for durability.
Yeah.
You know what I mean?
Hey, I gotta go, guys. I have to.
All right, no problem. All right, so all right, thanks, Jesus. Thanks for giving it. I think the most valuable thing so far was the blocks.
Yeah. All right, it was nice meeting you all, and
all right,
maybe we can meet again at some point in time in the future.
Okay, sounds good. All right,
see you guys.
Tomorrow. Okay,
take care, guys.
All right. So basically, so there's value in all this stuff. So
there's also the kids. Vex requires an engineering notebook. So you have the kids that are builders, you have the kids that are coders, and you have the kids that are paper workers.
Yeah. I got you. What do you find the best to be? How do you do it, Duke? How do you run your class?
Same thing. They're in teams, for like our competitions at the after school program. And, they figure out who does the documentation, and they can figure out who does the presentation, who has the presentation skills, and who can code and who can build.
Yeah.
So I just let them figure it out on their own.
Oh, that's cool. So you do the IQ?
Yeah. Yep.
Nice. And then is there a competition for that?
Yeah. Yep. So like for in school, all the kids are just building a base spot, and they can code it. They do that Vex code, that virtual Vex code VR that you were looking at, but they're pretty much basically doing the same thing. Now for the competition, our after school program, Vex makes a new event every year. So then they're trying to solve the problem in that event. And basically it's just putting pieces in a different location. But it all depends. Sometimes there's ramps, okay, like this one. Sometimes you're just stacking blocks, but the competition is different every year. Then, so that you customize your own robot. So all the kids' robots will look different. But these kids, as soon as they figure out, how to solve the different competition, they'll put their robot on YouTube, and then everyone will borrow their designs, but then people have completely different ones. None of them are all the same.
Yeah, I've seen them do that. In fact, what they do at my school is they look for the Chinese competitors because they somehow start the school year earlier or something like that.
Yeah.
That's crazy.
And they'll have unveiling. So you can look at this one, like that one, 555A. Like that thing's a beast compared
Where
to
is that? Oh, here?
Come in the kit. Yeah.
Holy crap, yeah. That's cool. Yeah, I don't know. Listen, I just want to work on motorcycles and stuff like that, but I don't know, there's something exciting about this. It's kind of cool. Like you got a situation where you can program something. It's like alive, it's interesting.
And it's the same thing. It's just exposure. You want to take you want the kids to take it farther than you could.
Yeah.
Like, I'm set at the block coding. I'm 45. I'm probably not gonna get any farther than that.
Yeah.
I know the Raspberry Pi or the Arduino stuff. There's coding out there you can just copy and paste into your screen. But like if you could expose a kid and they take a liking to it, and then they do it into high school, and then they can move on to it, then I'm happy with that.
Yeah, I remember I took this one kid. I took this kid to go to the auto show, and they saw they had a manufacturing robot. If I can spell. One of these guys. Yeah, like a serious one, like a big one, like this one, right? And it was in a cell. Oh yeah, this is a better. Here we go. Oops, I don't know what just happened. Anyway, oh yeah, something like this. And it was in a cell, and it was giving examples of moving stuff around. And nobody was really taking any interest. And I found the guy who programmed it, and he talked to my student because we were on a field trip. And that was it. He was hooked. So you're right. It's just exposure. Like I have no idea how to program these things, but all you got to do is open the kid's eyes to anything, to craftsmanship, to you're just lighting a fire. You don't have to be 100%. I mean, look, Jesus is like he worked in industry, like back when they made. He would like place the chips and stuff. Like it was very. He's an industrial engineer, and then. He knows code and all that stuff. So now he's really like integrated, whereas me, I'm just sort of like, all right, I never got into this. I wasn't into it growing up. And now I think it's interesting from a output advantage point of view, but not from I don't sit up at night looking at codes, so like, but some people do, some people love it. And those people, who absolutely love it, they're going to do wild stuff like this, where you're going to be able to take a road trip, and the car is going to identify everything on it, And so it's just a matter of, I think, Duke, you nailed it on the head. It's just a matter of exposure. What's nice is they're giving you the block code, so you can even just try it out a little. That's cool. Not everybody's going to turn into a world-class wood turning bowl master, I'll tell you,
I don't know any of them.
It's the same thing, because like you have the ability. Maybe you undersell yourself, because Tim, you have the ability to get people excited about bowl turning. Like you have the Instagram account. Let me give Timmy a little props right here. Okay. Oh my God.
Right. Maybe I wasn't exposed to coding as much as I was exposed to woodworking. Right. And maybe that's another thing, but I was exposed to documenting a design or the design process. Like I was, I was exposed to that in college, and we were taught that, and we were basically it's ZAVA.
Yeah.
Okay. I was exposed to all that, but and engineering notebooks are very similar to the design process. But guess what? That doesn't excite me either. I can tell you that much.
No, me neither.
So should I be doing a better job at having kids document? Yeah, you like that one there? Should I be doing a better job with students documenting their projects? Sure. But I just want to make,
I don't blame you. This here, you got to understand, you've been doing this a while, so you might need to hear this. When I see stuff like this, I'm like, this is exciting. This is like this is so cool. I think about like what you did. You had a lot of planning. You had to sandwich this thing, right? You gotta plane it, cut it up. I mean, what is this? You did this with the students?
Yeah, this was a bandsaw box, which is a project I just absolutely can't stand.
But you see, this stuff to me is like amazing, and so what's happening here is that you have somehow brought excitement to like detailed craftsmanship. And so that, oh Jesus.
You like that?
Yeah.
Yeah, my kids were ragging me on that one.
Funny. So that's the thing is that what the robotics instructor has to do is the same thing. Is obviously the high level stuff, but you also are able to come up with, it's very creative to come up with projects that excite people, That's why I did the electric car, because I was like, no, what would get people excited about working on the future of automotive? Well, we'll build a full-on electric car, and so that's kind of like, I mean, look at this. This is like wild. Like, that's so amazing. And you got it to be staggered and looks like staircases. It's so cool.
Yeah, that was a kid. That was a kid's project. So
yeah, that's awesome, man. So that's the thing is that, it's just up to the robotics instructor, and now they have the tools to make stuff like this happen. Whereas I think in the past, I mean, think about robots from the past. Like this is what we're dealing with here, like a 1950s robot. That's so stupid. I don't know what came up here, but
yeah, if you want to know how to draw robots, there you go.
Yeah, like this is what we're expecting,
Well, I don't know if you can say a 1950 robot because, look back to when the computer was developed. I mean, it was the size of a classroom.
Yeah.
Like the Univac, was it Univac or I think that's what it was.
Put a sci-fi here.
Yeah, most of these robots aren't even like functioning robots. It's just stuff in the movies.
It's just a dude in a suit.
Yeah.
Yeah. So so this is like, so like while this is going on, you got people doing like muscle cars. And so like this is an obvious choice. It's like this one or this one.
Yeah.
Which one's more exciting? SS Nova doing a burnout, what is that thing? Is that a Nova? I don't even.
It could be a Chevelle.
Oh, Chevelle, okay.
Yeah, the Chevelles and the Novas were very close to looking at each other. I can't tell them apart. My dad has a 70 Nova, and I can't tell a Chevelle from a Nova apart. I really can't. And there's somebody going to listen to this and be like, dude, it's the bumpers. It's always the bumpers. There's always going to be that one outrageous guy that's going to be like, it's the bumpers. And, I don't know what it is, but but that excites me.
Yeah.
You know?
Yeah.
Robots,
This
robots don't.
you're not like oh, look at this thing. Look
Like
at Timmy
that's
up there
cool.
controlling this leg thing.
That's cool. And the other thing is like when I do electronics and I'm doing electronics, like teaching about the integrated circuit and the 555, IC, like that doesn't excite me, but I do it, and I've gotten to a point where, yeah, it's pretty cool that you can do that. But now when it comes to Arduino, like when I cannot get excited about doing Arduino.
So the only way Hollywood got us excited about robots was to make it like a nightmare. So you either got a nightmare robot, or you got like too nice. Like, what was Johnny 5? Remember that one? That was actually kind of cool.
That was a Short Circuit.
Yeah, Short Circuit. I mean, come on. That was actually a cool movie. You know that there's somebody recreating this piece by piece, actual functionality.
They probably have it in some warehouse somewhere, on a movie set. Just hidden away.
NYC CNC. This guy here, they're actually making the thing. Here it is. That's the Facebook, I guess. But yeah, they're doing here we go. A part for NYC Johnny. It's a collaboration. Everyone's jumping in, and they're all making this thing. This is it. This is the guy's logo. And they're actually going to make the Johnny 5 from Short Circuit.
Like a couple years ago, I was slated to teach the second level engineering. Okay. And the second level engineering class used a lot of fusion, and there was going to be 3D printing and things like that. I literally had to get on a soapbox and explain why having me teach that class is going to be a total disservice, number one, to the students, and number two, to the program. When they had the guy that was better suited for that teaching a woodworking class.
Oh, that's crazy.
Like, why would you do that? You have teachers that have a specific subset.
Yeah.
Okay. That they have knowledge in. Why would you, without providing them training, throw them into a situation like that?
Yeah. Well, I mean, this is a school system. That's an endless topic of what the hell are they doing? It's like, of course.
So
they don't ask enough questions. You got teaching professionals, and they really should ask the teachers more questions.
So in the end, I got off my soapbox, and they made the change because they knew it's what is right for the students.
Yeah, 100%.
And it wasn't like I was slated for 5 sections of the one course, and the other guy was slated for 2 sections of the one course. So it wasn't like a one totally revamped these schedules. It was an easy flip. It was 1 for 1. And I think it was just flipping a couple prep periods and things like that. And then they decided to go ahead and make that change, which in the end was better for the students. So, am I going to be in a situation where, yeah, I got to learn fusion? Yeah. I mean, I have to learn this stuff.
Look,
and I'm not
automate this thing. This is yours, no?
Yeah, that was a kid. The kids cut. That's their prototype when we did this, but this was all pre-COVID, so we never saw the end of this project.
Oh man!
And the whole idea of that, go back to that. So that was a kid's prototype that became functioning, and in the end, they had those pyramid looking things on the side and the circle in the middle, okay, they were all going to be CNC'd and have
Cool.
that done.
Nice.
So that was part of the manufacturing course that they changed my program with. Now I don't have a problem with that, but you need to have an element of instruction on the CNC router. You know what I mean? On Fusion, on that kind of stuff. So
Right.
that's where I lack that skill. And I'll be 100% honest with you. I would have loved to have seen that project through the end, but with quarantine and COVID, oh, there's those slab boxes I was talking about right there. Go above, go back up.
This one.
No, go back. There was a ceramics project. No, go back to the thumb right there. That's it. That one. There you go.
What is this about?
Well, this is the ceramic project like I was talking about a little while ago. Like those corners are mitered, I believe.
Oh, I see.
So that's how that is done. I know the lids are mitered in. So
That's cool.
But anyway, so I would have loved to have seen that project, through the end.
Yeah.
But
Look,
we just couldn't.
You got to take your own advice.
Yeah, yeah. I mean, but like I said, how do you get excited in coding?
Hashtag fusion.
Yeah, I mean, listen, that's part of the reason I wanted to have this topic tonight, because I don't really know that much about the coding thing. I'm just trying to wrap my head around it. Here's the thing that I have to learn is CAN bus, and I got no choice. This is no joke right here. I even spoke with some people that I consider like an automotive mentor, and they were like, "Dude, you got to learn CAN bus." So this is CAN bus right here.
Yeah, I was gonna say, what is CAN bus? I don't never
Oh
heard of
my
it.
God, it's not good. It's scary. All right, let's see if this one. Yeah, this one's not bad. I'm not gonna play the whole thing, obviously, but I'll show you kind of what the deal is. So, like, all right, here you got a situation where, and nobody does a good video, even this guy.
But
right?
is this metalworking or is this like?
No, this is like cars.
Oh,
Cars right here.
so you're teaching this? You're teaching this to kids?
I am forcing myself to learn this so that I can teach it. So, for instance, like, all right, let's see, terminating resistor. Let's see, hold on. Okay, so let's say you have, what are they using this for? That's the thing. I don't even know what they're trying to do here. Let me see. Hold on. What is this? Okay, they're selling this unit here.
Does that excite you?
Well, it's kind of cool because think about this, right? You see, you can tap into the CAN bus in your car, right? Let me go to the Torque app, and you'll see the exciting part. See, it has to be exciting, right? Hold on. Torque app. All right, so this is actually pretty cool. All right, so like here's a good example. Yeah, here we go.
So is this parallel to the ECM? Is
Yeah,
that what you're talking about?
Yeah. So, but like that, what's weird about the OEMs is that they don't. Okay, so this is underneath the dash. This is a strange angle, but this is required by law to be a certain distance from the bottom of the steering wheel. This is your OBD2 plugin, right?
Yeah, that's how they read all the codes and everything.
Yes, and then what you do is it used to be very hard to have a very expensive code reader to get all these codes. Forget the codes. What you want is like real-time data. So you can actually hook this up and it'll Bluetooth to your phone, and then you put your phone on the dash, and then you're going to get this. You can make your own dashboard. You could put a tablet, and now you've got acceleration, you got vacuum, you got your speed, you got your load or whatever, Then you can add stuff. So you can say, "Oh, I want hold on, let's see. Here, you can add stuff and move it. Your timing advanced. You're going to get more options. I've never seen this video before. I'm just scrolling through. Here we go. Your coolant temperature, your intake vacuum pressure, whatever, and you can calibrate them. And then, what you're going to get out of this is that you now have more access to the stuff they're monitoring anyway. So the problem is that the OEMs have already done all the work, but they just don't give you access. So these aftermarket companies are giving you access, which I thought was that is exciting. Here's another video that shows it. Like, what kind of car do you drive on a daily? Let's say you got a Honda or whatever, it doesn't matter.
Mhm.
But now you've got real-time data, and you can now have access to all. I don't know. Let's see.
Which makes sense. That totally makes sense.
Yeah.
I mean, because you have those performance companies that tap into this.
Yeah.
Like
not a good
you can
video.
go buy a performance app that taps into this.
Yeah. Okay, here you go. So I've done this. So I stuck a phone in the car, and then you hook it and you make your own screen. So he's got, let me see what he has here. So he wanted to know about vacuum, his coolant level, his horsepower, his torque. You can get all this stuff. Some of it are estimates, basically, or calculations. But you've got access to this because you have access to the OBD2 port. Now, that's just CAN bus. And then the CAN bus has a code, and that code gets interpreted by this torque app. And that's all coding. So someone figured it out, and they were like, all right, well, we'll just start selling it to people. And that's basically it. Now, in a car like this, to imagine how much money you're saving. If you wanted to put in a gauge that had vacuum, you have to buy the gauge, you have to mount it somewhere, and then you have to tap it into the engine. No longer. Let's say you wanted to know your coolant temperature on your transmission. You would have to tap into that, so all that's gone. The hardware is gone. It's all digital now. So that's kind of exciting from a quick access, and you don't have to do anything. You literally take that plug, they call it like a dongle or whatever, stick it in the OBD2, take your phone, put it on a mount, and then Bluetooth to each other and download the torque app, and you're day one, you're in business. And it's $25 for that dongle. And the torque app has a free version. So you're in business already with any dashboard you want within 10 minutes, $25. I've done it. It's cool.
Right. So, okay, I get it. It makes sense.
Yeah.
But
Yeah.
what are you doing with that data? Like, what is knowing the vacuum going to do for me?
So if you wanted to, let's say you were trying to monitor something and you wanted to know it a little, it's the same thing as like if why do you need to know the temperature of your engine? What if you are pushing it harder than normal? Why do they give you any information at all? So it's so that you can monitor it, and you can make changes if you wanted to. So where it gets crazy is if you could make changes to the parameters, that's where things get nuts. So like right now, this is just reading, but what if you were writing? Yeah, that's where it would get interesting because they have something called a fuel map. So I never get into it, but fuel injection is basically a squirt of fuel at a certain time, right? So it's pretending to be a carburetor. It's a fake carburetor, right?
Right.
Now those parameters are set by the OEM within regulation of the EPA. But what if you could change them? You want to make more power. The car might make more power. They're just dialing it back because they're not allowed to sell you that thing because of the EPA. So you can go past the EPA, or you could make it leaner, or you could ask it to do things at a certain temperature. So it's basically programming. And that's what these, they call tuners. That's what the new generation of hot rodders are. They're tuners. And then it gets even better when it comes to the electrics because you're not dealing with organic material any longer. You see, because organic material is like you're dealing with gasoline. Gasoline is like an organic material, So I don't know.
Yeah, I mean, it is cool. I mean, in the end, it is cool. It is cool to
Yeah.
know what that is. And I know that maybe if your vacuum drops, say 2 values, whatever it is, I don't know what the value is for vacuum, but maybe that is going to tell you that, hey, maybe you have a problem with your,
Well,
tuning,
think about more tuning. So like, and then also keep in mind you can also keep records. So like you'll know your let's say your daily driving, you could try and improve your fuel economy by taking a look at the map. So let's see, this guy has air fuel ratio, your coolant level, your trans. So he's keeping track of that, but it's not just real time. It's actually it'll keep a map for you, like a log of data. I mean, I did it. I had it on the car for about a month, and then after a while, I was like, eh. So, but I do think on an old car it's interesting because I know that my truck doesn't have the same power it used to. So if I want to diagnose what's going on with it, that would help. There you go. Look at this. You got oil temp, revs, torque, throttle position, accelerator. And some of these are just in the app, in the phone app. Like you don't even need the car for this. So
my the pickup truck that I have a 2013 F-150.
Oh, nice.
And it has a lot of these things already built in. Like I get all this information, but I'm sure there's a gazillion other readings that I can get too. Like I know what the transmission temperature is. I know what I don't think it tells you like what the horsepower is, but you get a readout on the engine temp. You get a readout on the angle of the car, the tilt of the car.
Right.
So if it's going, like you can figure out what the grade is. So it is pretty neat that you can, you have that information there. But I mean, but knowing the grade of what the road is, it doesn't impact me.
They have all this on the that block code program, Vex Code VR too.
Really?
Yep.
No kidding.
That's the same thing as like these 3D printers. Before you can buy a 3D printer and just like level the bed and print, and then you're going by a temperature that's on your 3D printer's screen. Now everyone's hooking them up to Raspberry Pis, and they're seeing a whole bunch of different information you can get from the prints. The plate temperature, the nozzle temperature, why it printed this level. You can set where it raises the.
Yeah, you definitely want more information for sure.
Yep.
That's cool. Interesting. Yeah, so that's kind of like, that's the exciting part. And so with me, okay, so let's say you have electric vehicle, your batteries need what they call monitoring. So a battery management system, right? Now, if you have a cell that's high and you have a charger, your charger can't keep pushing, because if it keeps pushing, it's going to put that one high cell over the limit, and that's where you get a fire. So what it does is that high cell signals an alarm in the battery management system, which then would say, hey, charger, you got to dial back while we burn off some energy from this one high cell. Or we could skip it and charge up the ones around it, so all the other ones around it come up to the same level as the high cell. And if you're someone who's customizing, I mean, someone who drives a Tesla, you have no idea what's going on. It's like an ATM. You don't even know what is inside that thing. You just know money comes out, But if you're driving a car that you built with the students or you built yourself, you're going to need to know, where is that cell, that high cell? Where is it? How high is it? How bad is it? Can I replace it? Can I fix it? So that's where the battery management system comes in, and that's CAN bus. Have I put Timmy to sleep?
No, I was on social media.
Tim needs
I lost him.
Tim needs a data output for his lathes.
I get it. I mean, I know what the RPM is on the lathe.
Yeah.
Is that digital or analog?
It's digital. There's a digital sensor. It tells me what the RPM is.
That's cool.
You know, matter of fact, we just had our the maintenance guy that we have the service contract with. He came in and had to fix the one lathe because I guess the sensor was off or the sensor shifted on the spindle. So we weren't able to get that information.
Interesting.
Not really.
Yeah, no, that's cool. What happened to it? You have a maintenance guy?
Yeah, we subcontract our maintenance for all of our.
God, I don't have any of that. Everything that goes wrong is my problem.
Well, it is. I mean, I've gotten to the point where I could diagnose the problem and say, "Hey, I need this part. Send it to me," and then he'll send it to me. But he comes in and he'll grease all the equipment, like the planer. Like he'll grease the planer. He'll come in and, level the beds if the beds aren't right on the joiner. He'll come in and rotate all the cutters on the certain equipment. He'll come in and he basically polishes every tabletop that any piece of wood runs on.
What?
Yeah.
We don't have anything like that.
Is he from Nazareth?
Yeah, he is from Nazareth.
Dave King?
Yeah. Yeah, Dave King. He is amazing.
He's the man.
He is the man. So he comes in and does all that. So it is nice to have that for somebody to fall back on, in the shops.
This is it right here.
Does he go to your school, Duke? Or to
Yeah.
high school?
Yeah, Ron, he comes in like once a year and just like fine tunes the machines like better than you can. Like he can do
That's
something
awesome.
2 minutes where like for you to troubleshoot it will take you 2 hours.
Yeah, that's awesome. I love that. I didn't even know you could have that.
Yeah, and he comes in, and if there's a machine that doesn't have a guard or the guard broke, he can repair that.
Oh, wow.
Nice. And he has access to like purchasing different things easier. So like if you need an obscure part from a machine, where you would have to jump through hoops to get a purchase order, he can just order it, get it, send it, ship it, and then you can install it, or he can install it. So, and then of course he bills the district.
That's awesome, man.
Yeah, it is really nice.
Plus, it keeps everything safe. What I mean? So you don't get blamed and be like, well, we got this maintenance guy that, takes care of the machines, so it keeps them up to par.
That's
well,
great.
my school, way before I was there, was sued by him, or the district was sued, and they pulled him in on a case. So I guess so it is nice to have that as a fallback. And this guy's been doing this for like 40 years.
Yeah.
Here, we're gonna let me end the recording because we're off topic, but this was good. I think we covered a lot of the overview of robotics. All right, Shop Class Podcast.
But hold on.
What?
Hold
Timmy?
on. Let's bring it full circle though. In the end, you're gonna have robots and machines doing that.
Doing the maintenance?
Yeah.
Well, that's vision. That's vision software.
Great.
So like
that's exactly what you were talking about with the Tesla. I mean, you're gonna have a vision that you can hook up, like you can put a camera in front of a bandsaw, and then it'll tell you, hey, your wheel's out of alignment 1 degree.
Yeah.
Where you can't see it, but the robot will, or the camera will.
100%. 100%.
Of course, like you said, yeah, you want to. It goes full circle. So
Did you ever
robots
see?
are going to replace him?
Did you ever see Idiocracy? It's a
No.
movie. Anyway, yeah, I mean, we're here, we're there anyway. You know what? Let me add this as well. Whenever people say like, "Oh, the robots are coming," like I'm talking about, they're already here. The ATM, the automated teller machine, is a freaking robot. You know what I mean? All your cars are made by robots, so it's like it's already here, and we are cyborgs. What happens if you forget your phone like one day? You're like, you survive one day. But like, imagine if someone said, "I'm going to take your phone for 6 months." Like, no way. You wouldn't even tolerate that. So like, you're half computer attached to you all the time. You know. So I mean, we're here already. So I don't know. All right. I think I'm going to do so. You know what's kind of cool, and one thing I'll add is that you can do CAN bus with Arduino. I was just looking that up. Anyway. All right, so we're gonna get we got a robot. What's the robot's name that you hire?
I don't know. Maybe we should invent it, and then maybe we all can profit off of that. You know,
Let's give this guy a shout out. He's got a business card or a website or something.
who
all
the guy that does our maintenance?
Yeah, it's all work.
His name is Dave King. Name of his business is called Shop Specialties out of Nazareth. I don't think he has a website. Nazareth, Pennsylvania.
Nah, I even like wondered like maybe he'll come on the podcast, but he's probably not even want to come on the podcast.
No.
It's funny. He don't care. He's old school, right?
He is old school.
He's probably like, well, I don't know. I'll fix your lathe, but I don't want to talk to you about it.
No, actually,
he talks. He talks.
No, he talks because like this morning, he was in the building before I was in the building. He was literally he was in, and he sent me a text message, and he said, "Here's what I did in your shop. Fix spindle, lock, and speed. Put new flanges on a miter saw. New belt and Black & Decker. Oh, belt and disc sander, and left 2 riving knives on table saw 1 and 1 standard, one thin." So I mean, here you go. That's it right there. So he's a good dude. He really is.
Yep.
And he services pretty much most, if not all, of Jersey, and basically the whole East Coast or the East Side of PA.
Yeah.
Wow. Shop Specialties. That's cool. But he doesn't have a website.
No.
He doesn't need one.
Because it's only him. It's only him. And
so, but let's come full circle. You don't need robots. You don't need a website. You don't need anything. You just need like really good customer service and a creative way to, serve your customer. And that's what this guy does. So this proves it,
word of mouth. I mean, his is
word of mouth, do the right thing. Yeah. Like the robots are coming, but it's just another tool. It's like having another hammer, only the hammer can find the nail and hit it on its own.
Does he go to your conference?
I've never heard of this guy. Yeah.
I don't know.
He goes to ours.
Oh, yeah. I didn't know he goes to yours. I had a professional development night through the professional organization through NJTEA.
Yeah.
And we invited him out, but there was a conflict. He had a conflict that night, so he couldn't make it out. So, I mean, we invite him to stuff.
Yeah, that's cool.
Yeah. He goes to the TEEP one, Tech Ed Pennsylvania conference, but it might be just to meet his buddy Phil, who sells the saw stops.
Oh yeah, that's funny.
Well,
let me end the recording here. All right, Shop Class Podcast. Robots, no robots.
That is the question.
Yeah, there you go. All right, blend it up. All right, see you.